Welcome back, students. Continuing our video lessons on climate change. And in this video lecture, we're going to talk about the future, projections of where things might go in terms of the climate. There have been a number of studies to try to project the future of our climate. This is very, very difficult to project because there's so many factors. The graph that you see is one of these projections of what the future might hold. The y-axis is degrees Fahrenheit. Often we scientists talk about degrees centigrade, but in this case, the plot is in degrees Fahrenheit. And the x-axis is year, starting at 1900, going to 2000 and into the present. The projections then go into the future to year 2100. And there are three possible scenarios that are projected. One is called the low emissions scenario, low emissions of carbon dioxide, thus leading to less global warming. But as you can see, there still would be global warming due to the buildup of carbon dioxide that is currently taking place. The middle projection is what is called the high emissions scenario, in which case we don't bring into check our production of carbon dioxide. And then the top projection is the even higher emissions scenario, which takes into account not only inability of our own country to bring into check our burning of fossil fuels, but also other developing countries such as China and India and their increased use of fossil fuels. Now let's look at these three projections and some of the comments that are made in the publication that I've quoted below. In the low emission scenario, the average global temperature would increase to about 4 degrees above the value between 1950 and 1970, whereas the even higher emission scenario, the temperature would increase to as much as 8 degrees and, as indicated, maybe even higher if things really get out of control, up to 11 degrees Fahrenheit, for example, above the 1950 to 1970 value. An interesting analysis of this is something that we should all pay attention to because many of us live in the southeast or the southwest, where currently we experience, on average, in a year, about 60 days in which the temperature is above 90 degrees Fahrenheit, hot summer days. Under the high emissions scenario, this would increase to as many as 150 days per year in which the temperature would be above 90 degrees Fahrenheit. Can you imagine summer extending to almost half of the year? I've made a mark on one of the axes corresponding to 2 degrees centigrade increase in temperature. Now, yes, this plot is in terms of Fahrenheit, but later on we're going to talk about the 2-degree challenge of how countries around the world have pledged an effort to try to limit the climate change, the increase in temperature, to 2 degrees above the 1950 to 1970, or what is sometimes called the pre-industrial age baseline. It's also important to recall from another plot where we showed that the average temperature on planet Earth has oscillated, remember the ice ages, where it has dipped to as much as -8, -9 degrees, and has increased to 3 to 4 degrees above the average. The point is that over the most recent 800,000 years of the life of planet Earth, from data from these ice cores, the highest temperature has been 4 degrees above this global average. So in some of these projections, a 4 degrees increase in temperature would correspond to 7.2 degrees Fahrenheit, which is this next mark. And the concern is, of course, that with an increase of that magnitude, it would have a very significant impact on our planet. Let's talk about some of these impacts. In this slide, let's talk about the effect of global warming on sea level. The plot to the right shows data on the sea level over the past 20 centuries. Each of these bars is an average value for the sea level for that particular century. And as you can see, in the 20th century, that is this most recent century, there's been the greatest increase in the sea level. Now, what causes an increase in sea level? Well, with an increase in temperature, there would be a melting of the polar ice caps, converting the ice to water. So in the most recent century, there was a 15 centimeter increase in the sea level. 15 centimeters. That's about 6 inches. Now you may think, well, that's not a lot, and it's not a lot. But the concern is that with global warming, this would increase much, much more. Why is this significant? Well, first of all, 44% of the world's population lives in coastal areas. And if you look at this map of the southeast part of the United States and some of Central America, in red and yellow are highlighted those areas that are considered sea level at-risk areas. And of course, this will include the New Orleans area, but look, most of Florida and all of the coastal regions and even into the Mississippi Delta area. Well, how fast is the sea level rising? The graph to the bottom right shows satellite data, measurements of the sea level, and you can see that there is a progressive rise, and this is recent data. This is over the past 20 years or so, showing that there's an increase 3.4 millimeters per year. 3.4 millimeters per year is, I mean, that's not much at all, you might think. But over a 100-year period of time, if this trend were to continue, this would correspond to an increase in sea level of about a foot. And a foot is not a great increase, you might think, but the concern is that if this rate of increase really takes off and shoots up even faster than the recent trends, that the rise in sea level could be more than 1 foot, maybe 2 to 3 to 4 feet by the end of the current century. So one concern is the effect of global warming on sea level and what this would do to coastal communities, some of which are some of our larger cities. Well, how about the impact of climate change on agriculture and food production? Actually, this is a little bit more difficult to project for a couple of reasons. One, an increase in carbon dioxide in the atmosphere actually can promote plant growth, because in photosynthesis, carbon dioxide is one of the reactants. But on the other hand, increased temperature and changed rainfall patterns are expected to lower crop yields. The plot that is shown makes projections of the change in percent yield for different crops in different parts of the world with either a 1, 2, 3, or 4 degrees increase in global temperature. For example, if we look at U.S. maize and soybeans, the projections are that with a slight 1 degree increase in temperature, there would actually be an increase in the yield of soybeans. But as you go higher to 3 and 4 degrees global temperature increase, there would be decreases in soybean yield up to 30%. And similarly, and to a greater extent, with increases in temperature, there would be progressive decreases in the crop yields for U.S. maize, which is corn. So a second major concern of global warming is the effect on agriculture, which of course we need for food. Now I mentioned a moment ago the 2 degrees Celsius challenge. And this is an international consensus of climate scientists and world leaders that has resulted over the years from a number of international meetings, international panels. One was the UN International Panel on Climate Change that started in 1995, then the UN's Framework Convention on Climate Change, Symposium on Stabilization of Greenhouse Gases, the Copenhagen Accord, and most recently, the 21st Conference of Parties, called COP21 or COP21, which is also called the Sustainable Innovation Forum in Paris, December 2015, in which the countries in the developed world, about over 100 countries, signed agreements to try to limit the increase in global temperatures to 2 degrees above the pre-industrial age. Restating this, COP21 reaffirmed the goal of holding the increase in the global average temperature to well below 2 degrees centigrade above the pre-industrial levels and pursuing efforts to limit the temperature increases to 1.5 degrees above these levels. Now, this is a very significant challenge for all the countries that signed this accord. Might even be easier for the United States for technical reasons, but yet we have more of a political challenge in the United States. The little graphic on the left, the globe taking its temperature, 0.8 degrees is the approximate average global increase in temperature that has actually been measured from the pre-industrial baselines to the current value. And 2 degrees is the goal. But what would happen if the temperature increased to as much as 4 degrees centigrade? First of all, climatologists believe this would be the highest temperature on planet Earth over the past 30 million years, and that sea levels would rise by 3 to 6 feet, that droughts would occur over 40% of inhabited land, that this would lead to hundreds of millions of refugees, and that half of known species would become extinct. And in their report, the climatologists warn that a 4 degrees centigrade future is incompatible with an organized global community. Now, all of this sounds very dire, and of course, some people would say, but last winter it was very, very cold. So what about these observations that sometimes we can have very cold seasons? Actually, there have been very cold periods in North America, but as you can see in the graph below, which was from January of 2014, in this map, the blues and the darker blues indicate temperatures that are below the average for that part of the world for that time of year, whereas the lighter colors, the greens and even into the reds, are areas where the temperature is above the normal temperature for that part of the world at that time of the year. And as you can see, there's a great deal of variation around the globe. It can be much colder in North America at one particular point in time, but in the rest of the world, the temperature may be above average for that season. But why would it be so cold in the North American continent? Well, some climatologists think that the warming of the Arctic has resulted in a jet stream dropping down, undulating what is called the polar vortex, bringing cold air further south. The point is that it's complicated and that we shouldn't confuse the weather for one particular day with these global averages. Now we'll stop, and this is the end of our chapter on climate change. Before inviting you to go to the quiz, after which you can print some notes, let's just summarize some of the major observations. We started by talking about the observations of Dr. Charles Keeling of the increases in carbon dioxide concentrations in the atmosphere, and that these carbon dioxide levels were significantly greater than any historical levels in the past, those data coming from ice core measurements. We then talked about how from 1900 on there has been an increase in our burning of coal and other fossil fuels, and that carbon dioxide is a product of the burning of fossil fuels. We then talked about the greenhouse effect, the fact that carbon dioxide can absorb infrared radiation, and the effect being that it will increase the temperature in the atmosphere, which then leads to increased temperature in the oceans and on land. And we talked about actual measurements of the global temperature over periods of time, especially in recent years, where it seems that each year we record yet another higher global average temperature for that year. We talked about some other possible drivers of climate change. And then we talked about the international goal of trying to limit the increase in the global temperature increase to 2 degrees above the pre-industrial age. Now, how will we achieve these goals? We really haven't gone into that, but just very briefly, it will not be easy. It will require us to make significant changes in our energy economy to move to cleaner forms of energy, those forms that do not produce carbon dioxide. That is, things like solar energy, wind-powered energy, nuclear energy. But also, we would have to make changes in our modes of transportation, in our uses of energy in industry, and in our households, requiring us to use less electricity and to change the way we move from one place to another, perhaps walking or bicycles. My point in these presentations was not to be preachy about what we should do to try to limit the temperature increase, but mostly to try to explain to you what the issues are about climate change, to let you see the data so that you can be informed, and then you and the rest of our society will have to figure out how to deal with these challenges. To give you some idea of the choices we will have to make, I show a link to an online quiz where you can see some of the trade-offs that we as individuals and as a society will have to make decisions about. Now pause for a quiz, and after you complete the quiz, as usual, you'll be able to access some study notes. Okay, we'll see you later.
Seeds will rise from our temperature. The greenhouse gases And that's how we